Welcome to Study Loop.
This is the answer to Chapter 16, problem number 73 from the Smith Organic Chemistry textbook. This problem says one step in the synthesis of dodecahedrane involved the reaction of tetraene C with dimethylacetylene dicarboxylate D to afford two compounds having molecular formula C16H16O4. This reaction has been called a domino-Diels-Alder reaction. Identify the two products formed. Okay, and so the key here, the little tip, is that this is a domino-Diels-Alder reaction. And so basically this is going to be one Diels-Alder reaction followed by a second Diels-Alder reaction. Okay, and so I've drawn the starting materials here. So the first product that we get is going to be this one. So sort of a typical product we might expect from a Diels-Alder. And since an alkyne is one of our starting materials, we're going to have two double bonds in the product material. And so we'll have this. And then up here will be whichever one of the cyclopentadiene equivalents did not participate in the Diels-Alder. So let me move this down a little bit just so that there's room to see everything. There we go. Okay. Right. Okay. And so, like I said, we have basically a second equivalent of cyclopentadiene up here. And so what can happen now is that a Diels-Alder reaction can happen with this diene that we have up here. So the cyclopentadiene that's attached to our system that we made in the first Diels-Alder. So this can react here with this double bond being the dienophile, or it can react here with this double bond being the dienophile. And so that is what is going to account for our two products. And that's why this is called a domino Diels-Alder, because it's one Diels-Alder followed by a second Diels-Alder. And so following the green arrowed pathway first, so we'll get this. So just bear with me for a moment while I draw this. It is a pretty complex molecule and sort of difficult to draw. So one ring attached to a second ring. And so we'll have double bonds here and here now. And okay, and so again, this was if we followed the green arrow that I drew, and then between these two, there's also a bond. So this molecule would result from the green arrowed pathway. And if instead the red arrowed pathway was followed, we would get a similar molecule that would look like this. Let me adjust this a little bit. There we go. So again, this is going to be similar to the first molecule. Still double bonds here and here. But this time what's different is our CO2 CH3s are here. And again, this was if we followed the red pathway, the red arrow, and then that is there. Okay, so you can see these molecules are very similar. They really only differ in the placement of those two CO2 CH3 groups. Yeah, and so these are the two products that are formed. And if you wanted to count, just to double check, they are going to be C16H16O4, which the problem told us they should be C16H16O4. So there we go. Yeah, and so this is the product of the domino Diels-Alder reaction, or one Diels-Alder followed by a second Diels-Alder. And that's the answer to chapter 16, problem number 73.